Hi, I'm Jesse, and I run Ryan Moon's Nightmare Networks. So I work in academia, and we have a long reputation for running really crappy networks, and I have a lot of excuses for those. One of those is just that we've been around here forever. We've been on the network forever, and we've got, I don't know if any of you have a long to-do list of things to clean up, but ours extends back decades, right? We also don't run one network, we run lots of networks. So we're an ISP for our students. We're a research network for our faculty. We are an administrative network for our staff. We run PCI networks. We run ICS networks. We're basically a small city, right? So we have everything that you might find in a city, except it's all, our problem. In addition to that, we have about as much top-down control as you have in a city, right? I mean, there's lots of things going on, lots of jaywalking, et cetera, and are you going to, send a cop out every time someone crosses the street when they shouldn't? This is a problem that we have. So just a little bit of background, because I know we wanted to keep the background short, but at Duke in 2014, we implemented an automated defense using threat intelligence and deception. And I've done the translations for what we actually did, which is pretty straightforward. We scraped all the logs for attacks that we could identify. We bumped them up against a safe list, and then we shoved them into our border IPS. By the way, just a point of order, we don't have a border firewall. We have a border IPS. And there's a big difference culturally in our organization, because we don't run firewalls because those are bad. But we run an IPS. Wink. Threat intelligence. We basically we pulled in open source lists of bad things that seemed to be applicable to our area and didn't cause a lot of false positives when they went against our safe list. And we also took all that data that we scraped out, all the IPs we saw, just egregiously attacking us, and we would share that out with people who are interested in having that data. One of the big partners for that is Ren Isaac. I'll mention them again later, but that's to share it out with the other 550 member schools for Ren Isaac, et cetera. And we started using deception, which means we deployed some honeypots in our network, because that was a really easy first case to make for these are things that we should be blocking, because it's very difficult to block things in a large academic network because there's so many different things going on at any point in time, and everyone's really, don't stop the research is one big thing, because there's lots and lots of money in research, and if you hold up the Nobel Prize, researcher, and they get pissed off, maybe they'll go to Princeton or something like that. So that's sort of an issue. And then we also have this medical center and like hospitals and clinics and stuff, sort of on another network, but they rely on a lot of our services, and so if we screw that up, babies will die. That's a very common thing to hear. I mean, obviously that would be terrible, but it's pretty unlikely. But honeypots are great, right? And we sort of started down the road of using a modern honey network because people were talking about it, and it made it really easy to deploy different types of honeypots and get all the data back. And that was one of our good sources of information as we were sort of heading down this road. So what did that do for us? So around 2017, we started to look at some of the results of that. And so when we were just using our vendor-provided threat intelligence feed on our border IPS, we were blocking around 10 million connections a day or so. And aside from IPS alerts and all that sort of thing, but just the, what we're stopping right at the border based on threat intel. When we started pumping our own stuff in, we went up to 1.5 to 2.5 billion connections a day that we were stopping, right? So management loved that. Man, look at those big numbers. This is really great. But the thing that I really liked was that the number of IPS alerts that were rolling into our pay-per-gig SIM and the number of alerts that our analysts had to look at went down by 85%. So we were getting like 8.9 million events per month in, and we dropped that down to 800, 900,000 per month, which is still a lot of alerts, but that's far more manageable and a lot less noise, right? other interesting things that sort of came out of this were when the Mirai botnet was kicking, and everyone said, well, it's looking for 2323, and we would start looking at our block data to see, like, okay, here's the things we blocked. We count them. What port were they actually asking for? Because we weren't blocking on a specific port. We were just blocking the IP. And 2323 was pretty high up. And then all of a sudden, this other port just like shot to the top of our list. And we're like, this is weird that everything's asking for this new port. What's going on? We were busy. We didn't look into it. But 2 days later, we see an Internet Storm Center blog post, page, what have you, saying, oh, Mirai's now looking for this new port. It's like, oh, that's awesome. We could have found this like a couple days earlier if we had actually been, digging into this data. But it really showed that there was some potential in this data as well. And we were averaging about 17,000 unique IPs a day that we were able to share with other people that if they could do something with it, great. So the question we really had was, we started asking around to other schools, are you doing something like this, or do you have this data? Can we have your data? And we really found that really no one else was sort of doing this simple cycle, right? It seemed pretty straightforward. I mean, my argument was, listen, I know you're blocking something, so can you just write it down and send it to me somehow? Like, just give me the information. Like, you are doing something, so why isn't this happening? And how can we help this happen? I had a bunch of random points. I wasn't quite sure where to fit in everywhere else, but we do automated blocking, right? So we detect it, and there's no human in the loop. It just shoves it right into the blocking at the edge. And to do that sort of thing, you have to have a safe list. If you do that without a safe list, it could be a resume generating event. And even with a safe list, we've had so many different ways. We've learned a lot about how to generate a safe list and how to make sure you keep a safe list running and how to make sure you don't screw that up. I think the best part was when I got woken up at 1 in the morning because there was a URL that was a bare IP address, /1. Yes, sir? Most of our detections are based on TCP, but we block for anything, right? So absolutely, right. So we've tried to avoid anything that's UDP based in terms of doing detections for automated blocking for just that reason, right? And because even though we do have a safe list, like there's still plenty of opportunities to fail in that space. A lot of people argue that scanners aren't worth blocking. Like, why would you block a port scanner? And well, for me, I mean, the IPS alerts alone are worth it, but I say you're so fancy with your firewall and patch management, right? We don't have inbound deny, and we have devices that people are putting on public networks all over the place all the time. We average 40,000 unique devices a day on our network. I don't know what the churn is on that, but it's pretty sizable with students bringing things in, trying new things out, putting things on the network. Still plenty of places where a public IP is your default IP address. The big thing that really drove me was when I started looking at what we were getting out of the ISACs, and I compared that to what I could get out of open source. There was almost nothing member contributed, or rather, there was almost nothing that I was getting out of the ISAC that I couldn't find somewhere else. And that was disheartening. So, the hell is a stinger? So a stinger is a great backronym that our CIO came up with for this project that we decided to do. It's Shared Threat Intelligence and Network Gatekeeping with Automated Response. Essentially, the idea was, for us, honeypots were a great source of data. If people can understand honeypots, they can understand like this idea that, if something talks to your honeypot, it's probably up to no good just on its face. There are exceptions to that, of course. There's the good scanners that the gray noise guy talked about, et cetera. But, for me, there's a lot of nuance into whether I should block them or not. But the point is, if they talk to a honeypot, they're probably bad on its face. And if they start trying to log in, they're definitely bad, et cetera, right? So a lot of people can get behind honeypots as being a great source of data for blocking on. So if we give someone an easy way to deploy a honeypot, and we give them an easy way to sort of summarize that data up and bump it up against the safe list, and then put that into whatever protection device they may have, they'll probably be pretty comfortable with that, right? Like people can get down with that, right? That's a pretty safe thing to do. And what I'm really hoping is that if we can get enough people doing this, and once people start doing this, they'll realize, hey, you know what? I've got this other report of really bad things that's always bad. I can just pump this right into this pipeline, and it'll go in, it'll block. And more importantly, I'm going to start sharing this with our friends as well. So what are the big things here? Oh, there's one other sort of purpose to this, and that is because we're academics, we want to build a research corpus, right? There's not enough large sets of data around attacks that's nicely labeled with like metadata around like these schools saw these sorts of attacks, you know, these classifications of schools saw these sorts of attacks, etc. So one of our goals with this project is to collect a research corpus as well. That's what we got the grant money for. We got grant money for this, by the way, right? So we've got a couple years for what sounds like a lot of money until like the overhead 60% comes off. And it ends up being like we're funding like a couple of our existing positions for a couple years to basically make honeypotting technology easier, et cetera. Make it easy to deploy, make it easy to get this information back, make it easy to share that information. But the big thing for me is I want to use all of this data to actually make the internet a better place, right? So one of the things I'm going to ask later is like, how can I give this data to you and you can do something useful with it? So architecture, did anyone here run MHN? Anyone run MHN? I see my honeypot people. Only 3 or 4. Okay. So this is a diagram of basically what MHN was doing, and the real big thing is all this stuff here in the dotted lines. It's kind of a big mess. There's a lot of things going on. There were actually things in here that we've already ripped out, right? Like there was an Elasticsearch instance that was, you know, coming up that we had ripped out. But there's still Redis, and there's SQLite, and there's MongoDB, and it's got HP feeds to do transport, and it's, anyway. But the nice thing was you could deploy all these different honeypots and all the data could come back to one place, and you could dump it out into a log that you could then pull into a SIM or just parse however you wanted, et cetera. And we added in this little bridge right here. Who here has heard of CIF, Collective Intelligence Framework? Ah, a few more. That's there we go. Yes, yes. We move slowly. We move slowly in the higher education, but there is a lot of use in higher education, right? And we chose it. It's relatively straightforward. It does these basic things like, you know, take in an observable, keep things normalized, generate a feed based on criteria you give it, bump it up against the safe list. Like this is all functionality we didn't have to write. So this is really good for helping us move our project along. And just to give a sort of overall view, you know, the idea here is we're going to have 12 to 15 different schools who are running these CHN servers. We forked Modern Honey Network, by the way. We called it Community Honey Network because we're really creative with names. And so a lot of the internals are the same, but we have changed a bunch of things around it. So I should have mentioned this earlier. The biggest being we Dockerized all the different components, right? So now you can spin up a CHN server and deploy some honeypots in 5 to 10 minutes if you can, you know, copy and paste some Docker Compose files onto a couple of VMs, and that's pretty nice for folks. But the data flow I wanted to point out here is that this summary data comes up to CIF, so that's just like this time, this IP address, you know, this sort of broad classification. This is the person who provided it. That sort of stuff is going up into CIF, and any of the other partners can reach up to CIF and pull that data back down and do things with it that they want. But we also have an option with HP feeds where if people want to, they can actually trade the raw data as it's coming in from the honeypot. So, you know, this IP tried this password, and, you know, this IP, you know, once it got on the box, created this file or did this curl, those sorts of things. Those sort of things can be traded directly between partners as well, and they don't have to share that necessarily with everyone. But the summary data, we do want them to share with everyone up there. And so we've been running Modern Community Hunting Network for about a year or so. We've been banging on the code. And it's not without some issues, some operational shortcomings, I guess. One of those things is there's really no good monitoring of the honeypots. So like if your Dionea honeypot fills up the partition because WannaCry is everywhere on the open internet, you don't get any sort of feedback that the honeypot got filled up unless you're doing some sort of external monitoring yourself that, maybe you set that up, maybe not. It would be really nice to have that sort of integrated into the GUI because, that'll help people, keep things up and running and collecting good data. Speaking of data, there's a lot of it that's left on the table, right? If you've ever used MHN, you know that there's a lot of data that's coming out of those honeypots that is never making it into that web front end, right? You can dump it out into a log file and get a pretty good amount of data that way. But there's a lot of it that's just sort of left in the Mongo database, and you've got to go digging it out. So surfacing more of that data is an important thing for us to do. There's also some data that just doesn't get pulled back by MHN, right? All the BI stream stuff out of Dionea, that all stays on the individual honeypots. That never comes back to the central server. So if you want that, you have to go get it yourself or come up with some new mechanism. So V2 is something we're working on with that. Deployment is still that MHN way of copy this curl command, pipe to sudo bash. It's basically the same thing, except it's writing out a deploy script that just writes out a Docker compose and a small sysconfig file and then brings it up. So that's fine. It gets things up and running really fast. But if you want to say, I want to change the port this is listening on, or I want to make some adjustment to an internal configuration file, you can feel free to change it in the interface, but then you have to go back to that box and you have to rerun it. What we really want to move to is more of sort of an Ansible model of, we have credentials for this box, and now we can go in and we can change whatever we need to change, dynamically, right? So the CIF bit is totally a bolt-on and mostly external, and it doesn't let people actually look at any other external feeds alongside their honeypot data. So the plan is we'll integrate CIF more closely into the product so that you can say, hey, this URL, I want to pull down this feed and I want to map these fields and go, and then it starts showing up, and you can actually compare that with your honeypot data. It'll open up a lot more doors for understanding more about the data that they are collecting from their honeypots, right? This is sort of a conception of what 2.0 might look like that's sort of covering all those points. I'll come back to this when I ask you for a favor at the end, because favor, right? The thing is, swapping out the database stuff, probably for Elasticsearch, using Ansible and CIF, rewriting a front end, which we're no experts in, but planning to put an API over everything else so that we can at least do things on the back end. And when we eventually find a front end developer who actually knows how to develop things that people can use, that'll be right there for us. And in the meantime, you've got Kibana that you can actually go in and dig at that raw data if you just want to go see what you can find with Kibana, etc. Also using FluentD instead of HP feeds. I don't know if anyone's kept up with HP feeds and it's a peer-to-peer sharing of this data, but if you start looking at it, you'll realize that some of its dependencies are falling out of pip, and it's not being maintained in any way. So we need a replacement for it. We don't want to write it ourselves if we can help it. FluentD makes kind of will make a nice transport for that log data. And we can put some of this other stuff we want to pull in, monitoring data, et cetera. We can just shove that stuff into FluentD. And then likely we'll see Prometheus for doing actually monitoring of the honeypots and saying, pulling load and all those sorts of things out of there. Really quick, I wanted to talk about data, and then I'll get to the part I really want, which is the questions and suggestions from you all. But so we've got 4 deployments right now. Duke is one of those. That's about 65 sensors, and we've pulled in about 197,000 unique IPs over the course of 30 days. Sources. sources, about 197,000 sources. We filter out the inside stuff, generally speaking. This is all external stuff. This is outside in, sorry, yes. On the deployments, obviously, we deploy them everywhere. We've got some in cloud providers, which we found very useful for getting a lot more data. I was laughing a little bit when the gray noise person was speaking because a lot of their data really lined up with what we were also seeing with our own data. But just some basic stats. You can see that we don't have many sensors deployed with these other partners right now, mostly because they did it as a favor because I kept bugging them to deploy it so that I could have some data. And they're like, fine, I'll deploy 2 or 3 because that's what I can get out. But we've actually got a lot of traction with fellow CIOs, et cetera, to actually get this done in a larger fashion to get some more data out of here. And probably the last one that I think is really interesting is sort of a crosstab of the unique IPs to see like what the overlap looks like. We obviously got a lot of IPs just but we had roughly, with our sensor network with 50 sensors, 55 sensors, we're seeing roughly 50% of what the other people saw, if that makes sense. So partner 1 here, we had 3,500 IPs in common out of the 7,700 that they saw. Partner 2 with us, we had in common 6,300 IPs out of the 10,000 that they saw. And for partner 3, 10,000 out of 16,000, et cetera. And I'm not sure what that means yet, but we have a lot of questions that we really want to ask about this data. And what we're really trying to get to is how can we best use this opportunity for deploying these sensors and gathering this data about attackers? How can we best use this opportunity to feed not just our research corpus and fulfill what we said we were going to do on the grant, but also help the rest of the community solve whatever problems they have? Yes, sir. Sure. So the question was, would we be willing to share layer 7 type data so that people could build better controls? We absolutely would, except I don't think we necessarily have that data being collected today. But I would love to hear some ideas on how we might collect some of that data, right? Because we're using upstream honeypots, right? Because we didn't want to start messing with the individual honeypots at this point. So we just said, hey, okay, Cowrie, hey, Ammon, hey, Glassstop, hey, Dionea, we'll just take the upstream projects, hook in the logging, and deploy it and pull the data back that's there, right? Yes, sir. Yes, so the comment was that Dionea writes huge logs of bystreams. Yes, that's why most of our Dioneas died after 2 days. Because we filled up the disk. Yeah, and you've been pulling that data off, and we had not. So we did write a temporary fix, which was to rotate that log hourly, which at least keeps the honeypot up and running. And then we're trying to think about the best way to pull that sort of data back so that it can actually be mined and be useful, right? Yes, sir. Yep. It is not required that they be specifically on education networks. We did promise to get them deployed to at least 15 institutions, crossing a variety of sizes of education institutions, as well as like regional network providers. But there's no reason at all that we can't have sensors running outside of education networks, and we would welcome that data for anyone who's willing to do it. We could handle the cross-vertical. We would find that data very interesting because we do have a hypothesis that higher education attackers tend to sort of attack higher education, right? there was, or jump from there, that's exactly right. Sometimes start from there, that's right. We have very creative students. Yeah, I think one of the interesting things that happened when we were first looking at open source feeds and we're trying to determine like how applicable is this feed to our environment, what we would do is sort of, we would put it in a monitor mode where we wouldn't necessarily block it, but we would keep track of how many of those IPs on this list actually came to our network in this period of time that we would have blocked it. And with the open source feeds, we found that number was typically a little under 10%. And even with that 10%, we got a lot of blocking done, which was great, but felt like it wasn't very applicable. And is the problem that it's not applicable or that it wasn't timely? We felt like timeliness was probably the issue with our vendor threat feed because they're collecting a bunch of stuff and they've got to munge it all together and process it, and they've got to, well, we imagine that they use a safe list, although sometimes our own evidence would say that they don't. Like when they blocked the PAT address for one of our large medical center facilities. That was really nice. That was a long weekend. But when we did find another school that was generating their own list, and they were willing to share it with us. And when we took that list in and we looked at it, we saw between 50 and 75% of the IPs that they were blocking, we were also seeing and blocking. So we think that there's a lot of commonality with the education stuff, but having a sensor outside of that would help give us some more perspective. That's right. That's exactly right. That's exactly right. Sir?
Just I know that there's folks at Harvard, specifically one guy who was Dr. Rice.
Yes.
So where are you at with NIST? What's holding you back? Have you already got one?
So the question I actually had here was MISP. It was sort of going towards how can I share this data in a useful way? We've got a MISP instance that's been up and running and collecting whatever community events would come to it. It's not really hooked into our other systems. It just sort of sits there. And we query it from the Hive and stuff like that, but we're not really using it fully. So I'm not as well aware of what some of the issues are. I've heard people say like there's an issue with pushing large events in. So if I push in, 30,000 IP addresses each day and share that with anyone who's connected, would that make people mad? Would they start blacklisting, anything that came out of our MISP instance, or would people find that useful, right? Yes. The context with the share, how much would be useful, right? One of the things I don't feel comfortable sharing is like what particular sensor network it came out of. Port targeting we could get, yes. And certainly the honeypot type that it hit, because that's going to tell you a lot. But we do have one small problem with the ports, and that's because we Dockerized everything. We can do one-to-one mappings, but that doesn't stop anyone from changing what the external mapping is, right? So, we might bind the port in Docker on port 2323, but it's actually point 23 on the outside that the traffic's coming in on. But the Docker container only sees 2323. So when it writes its log, it's like, you attacked port 2323. And we know what we mapped it to, but that data's not quite there, right? Which is another sort of V2 issue we want to resolve, because the port data would be very useful, right? Essentially, yeah, we're Docker natting it away. For the ease of deployment, we gave away a big piece of information. But who should we be sharing this data with? Who? All right, I'm not surprised that this crew. All right, I got another one. But how do you want it, right? Like, should I be pushing events into MISP? Should I?
I would suggest you push it in MISP and instead of involving get it in there and throwing that. There's a couple of those
Okay. I mean, it's a start. It's just sort of push it out. What about other ideas for using this data, right? I mean, one thing that I think the gray noise guy alluded to, and I've been thinking about for a while, and I've even had some initial discussions with some of the infrastructure as a service providers, is, hey, if I can give you a feed of all of your IPs that are attacking our honeypots, maybe you can do some customer shutdown, some remediations, right? Is there any sort of other ideas around using this for trying to push remediation of these bots? Anything like that? I'm trying to think of other use cases. I want to use this. I want to squeeze as much as I can out of this data. Right? Will we be willing to share the implants that we get on the honeypots? Absolutely. Okay. Okay. Some sort of. I've actually been thinking after the presentation on Phoenix, which is the second time I've seen that presentation, and now the second time that I'm totally going back to work to make this happen. That would be a great tie-in, right? You know, the things that come into the honeypots, drop them into some sort of sandbox, and then push everything that comes out of it. Right. Who? Okay. So there's someone that I should talk to because they've already got a sort of process set up for doing sort of AS notifications based on incoming attacks. That's awesome. Yes, sir. D-Shield project integration. That's right. Yep. Yep. Sharing those things back with D-Shield. Yep. I like it. Thought I saw a hand over here somewhere. Unless they were also going to say D-Shield. Yeah.
I just say if we can get our hands on the data, we'll look at the correlations basically with our network.
Mm.
And maybe we can go from there.
Okay. Okay. Okay.
This is where most falls down on large correlations. That's what I'm not really sure about. So it lines up quite
Right.
well with what we're trying to do.
So the comment being that, you know, with large correlations, mist can fall down, which is kind of why I'm worried about just starting to shove events in and people are automatically correlating, et cetera. What would that mean for them? Okay. Fair enough.
We'll figure it out.
Fair enough. Put it in and let's see what happens. Daily, yeah, daily was what I was going to go with because doing anything, right. There's going to be a lot of overlap because things that hit the honeypots, they tend to keep hunting the honeypots, especially when it's WannaCry. Any suggestions on this architecture bit? Because we're totally making this up. I mean, we're not developers. We're at best systems administrators who can do some Python, which is why we've got Falcon listed there for the API, because that hopefully makes it easy. Yes, sir. Okay. Okay. The suggestion was to put something between FluentD and Elasticsearch to make sure we don't DDoS our Elasticsearch instance. Like RabbitMQ. Tell me more about this asset deploy. Tell me again. ACID compliant database. Gotcha. Okay. So we have suggestions on things to make Elastic faster. One of the things I sort of glossed over is one of the honeypots we're integrating now that was not in the original MHN instance was UHP, Universal Honeypot. Anyone heard of Universal Honeypot? I got one. Matt Carruthers, I think, is the original author. At least he's the GitHub I pulled from. And what I love about Universal Honeypot is that it can emulate services just with a big blob of JSON, which we're hopeful will let us be able to prototype things fairly quickly and get things out fairly quickly. We have a part of the grant where we talked about emulating medical devices, et cetera. And if we can just get as far as like presenting what that dialysis machine would look like on the network, that's like a great start, right? Sir? Bad story time. Okay. Well, it's Docker, so we just down it and up it, right? And then we'll just down it and up it again, right? Yeah. There's a lot of internals I sort of glossed over on that, right? Like some stuff still does run as root inside Docker, right? And that's one of the things we want to get rid of. Internally, we're going to be running OpenShift, so making it Kubernetes friendly is going to be a big priority. So, I mean, that's not something we want to like put on the project page as like we're definitely going to do that, but it's something we're going to have to do. Because if we say we're going to do it, then we have to also document it, and that's probably a pain in the ass. But we want to make it work in our environment, right? So chances are it'll be able to work in others. Sir? Right. Right. That's right, right. So the comment was that with some of these botnets that are really active, like WannaCry or Mirai or what have you, you get a lot of noise in these honeypots, and that's absolutely true. So one of the hopes is that as we start collecting enough data, we'll start winnowing it down, right? Take some big chunks, like, oh, this is obviously WannaCry because of the commands that they ran, or because of the hash that came down eventually, or what have you. We want to start clustering those things and peeling those off. Because then it won't be real time, but after the fact, we can start to pick out like, hey, this is pretty unique. This little bit here is really unique that came into here. The other thing that I didn't talk about was a number of folks who are running it, and we do this as well, are interested in running it like a separate instance just for internal stuff. So you go put it with your SAP servers, and you go put it with your PeopleSoft servers, and you go put it in your secure enclave, and you hope you never see a hit on it. But if you do, that's a nice little warning, right? And it's cheap enough to put these things up that you can kind of get away with that. Other interesting things like we're probably in the next couple weeks, we're going to point our default route to a honeypot system. So when you come in, once you get past the edge into the core, if you don't have a more specific route, you go over to the honeypot. So basically, what did I have to say to implement it? I said, hey, imagine if all of our dark space was one giant honeypot. And man, my leadership got really excited because we're really excited about this project, and right, it's had big impact for us, and we want to see what we can do with it and what kind of value we get out of it, and set an example, and hopefully push this out to the rest of the academic community as well, right? Because like I said, this is a big stalking horse for me of like, if you can build this simple cycle of collecting data, acting on this data, sharing this data, like once you do it once, you start doing this with more and more and more things, right? Because I want to solve this problem of people. There's no reason that, someone should be able to, come punch me in the eye and then walk down the street and punch UNC in the eye. Well, I mean, maybe we would let them, but, ostensibly, we want to protect the entire community. And if we can get a wide enough sensor network, maybe we can like actually start to pick out like what's mass exploit, what's actually coming just at us continuously. You had a question, sir? Yes, I should have mentioned that. When we started doing this, we knew that we would have this problem of the ever-growing block list. So we all sat down and we did a really scientific endeavor of 7 days sounds pretty good. And we've never had to change it because we haven't had anything that, really bit us in that space. In a hallway conversation with the Gray Noise guys, because obviously he's doing a lot of honeypot type stuff as well, so I missed 2 talks talking with him. He said that based on his data, it's somewhere over 4 days. So I feel pretty good about just guessing our way into 7 days. Yes, sir? Do we have stats on IPs that were unblocked and blocked again? We do have a report that runs on that, yes. So I think we call that our most wanted list. And I think at the top of that list are people who've been on that list for 58 weeks or something like that. Every now and again, we'll go through and call that list, and we'll actually put them into a border ACL, which we don't log or anything. You can't talk to us anymore. So that's one way of sort of filtering that out. But I think going forward, we're in this position where we've got a wealth of data, and now we're really trying to figure out, oh man, how much can we squeeze out of this? It feels like a lot, right? And so there's a lot of things that I want to solve. I want to make operational so that these things just click, feed the machine. That's right. That's right. Who wants to run a honeypot for me? Let me see. Oh, more. All right. Awesome. Awesome. I love it. I love it. Okay. Well, that was really all I had. So there's a QR code that'll take you to the documentation for Community Honey Network. I tried to make it big, so maybe you could even see it in the back. I don't know. Team-Stinger@Duke is an email address that goes just to us devs. And then you can also post things on GitHub and stuff like that. I'm sorry. I started a Gitter channel for Community Honey Network. I think it's me and Alex on my team who's in there. And then we've got sort of a blog posty page on Stinger. It talks a little bit about it, links to the documentation. I post some use case stories there every now and again, as we're sort of learning things and trying things out. So. All right. Thank you.